All right, so I'm going to say good morning. I don't know what time it actually is in your town, but in my town it's morning. So good morning. This is going to be a video on how to multiply polynomials using the box method. All right, so I'm also going to do a separate video for FOIL. I also do have a video that kind of combines them and just is like an overview, but this is if you haven't done either of these in a while, if you wanted to see individualized problems and you didn't want to see both of them all together. All right, so all right, the reason that I like box method is because if you are a visual learner, then FOIL and distribution can be very chaotic with all of the swoopy things showing you where you're multiplying. And box method works beyond 2 by 2. FOIL only works on a 2 by 2. Distribution works on anything, but FOIL only works when you have 2 terms and 2 terms, because you do your, let's see if I can do this, first, outer, inner, last. Anyway, that might have been backwards. I can't tell. Anyway, but I like box method because if you had a 3 by 3, if you have a 2 by 3, if you have a 1 by 3, a 1 by 2, a 4 by 4, a 4 by 5, you can do box with all of those. So I think it's a good method to learn, even if it's not your favorite to use. Like, I personally use FOIL when the problems are small because I'm faster at FOIL, because that's how I learned it. But I like box method when the problems get big because it will work that way. So what I'm going to do is I'm going to show you a couple of each size. So let's start with, for example, something like 5x times x squared plus 3. All right, you could definitely do this distribution. Personally, I would do this distribution. All right, but if you find that distribution confuses you, then this is a great box method problem, even though it almost looks too small for box. Notice in the parenthesis I have 2. Outside the parenthesis I have 1. So this is a 1 by 2. So when I make my box, I usually make the longer side across the top. I'm more of a horizontal person than a vertical, but you can do vertical. I'm going to do 2 across the top. So I've got my x squared plus 3. I make sure I hold on to my signs. One of the biggest mistakes that students make is they leave their signs out, and then when they go to collect like terms, it's a mess. All right, my 5x is a 1 term, so I only need 1 length on this side. So my box now is 1 row and 2 columns. All right, and now I'm going to multiply into the box. Now, what you might have forgotten or maybe haven't thought of in a while is there's a little invisible 1 on this x, and there's an invisible 1 in front of that x squared. So when I multiply, what happens is the numbers, the coefficients will multiply. And then when you multiply x squared times x to the first, when you multiply, what happens is the powers add. And here's why, if you haven't done it in a little while. Here's my x squared times x to the first. X squared is x times x. X to the first is x, so how many are there? There are technically 3 of them. So when you're multiplying with variables, the powers add. That's technically you're multiplying, but what happens is the powers themselves add because of the way variables multiply. All right, so what I'm going to do here is I'm going to take 5 times 1, which is 5, and then x to the first times x to the second gives me x to the third power. All right, when you are multiplying, you always create more power. All right, so if something has power and something has power, they're going to create more. If this one has power and this one doesn't, you're still going to create a term that has power because this guy didn't, but this guy gets to bring his, okay? Or lady, doesn't have to be a guy. All right, now I go ahead and I'm going to multiply in the 3 and the 5. So 3 times 5 is a positive 15. Notice I put my sign there so I didn't forget it. And then I have that x to the first. You can leave the 1 on the x or you can take it off. It doesn't matter. It's the same thing. And then you want to write your answer. So I would have 5x to the third plus 15x. Now, can I add those together? I cannot, because hopefully you remember from adding and subtracting, these powers are not the same. So this bucket has x to the thirds in it, this bucket has x's in it. They can hang out together in a sentence, but they're never going to combine to make more. Now, when you start to multiply bigger polynomials, you will generally have like terms that have to combine, and we'll do that next. So this is considered a monomial times a binomial. All right, and you can do it with distribution. This is just a way you could do it with box method. All right, next one, and this is one you're probably more familiar with, because even if it's been a while since you've done Algebra 1, for some reason, this is one, well, not for some reason, but this is one of those things that because teachers do a whole heck of a lot of it, a lot of times students do really well with multiplying, and where we struggle a little more is sometimes with factoring, which is unmultiplying. All right, so let's do now a binomial times a binomial. So let's say I have x plus 4 times 2x plus 3. All right. And I went just for positives here so that it was not a very complicated problem. If you like FOIL, you could do FOIL or distribution with this, but I'm going to go ahead and do box. It's a 2 by 2, so what will happen is I'll have 2 rows and 2 columns, and I'll get this nice 4-square box. It doesn't actually matter which binomial you put on top and which binomial you put on the side. In fact, I'll do it over here the opposite, so you can see we still get the same answer. All right, so here I'm going to put x plus 4. Here I'm going to put 2x plus 3. Here I'm going to put 2x plus 3. Now, you wouldn't do both of these. Like, please don't think you have to do the same problem twice. I'm just showing you that if I wrote it this way and you're like, oh, that's not how I would have written it, I just want you to see that you're still right. All right, I am going to come in and put in my little invisible ones. If you don't need them, don't put them on. I just put them on in case there's anybody watching that needs them. And now I'm going to multiply into the box. So first times first, here I get 2 times 1 is 2. X to the first times x to the first gives me x to the second. Now I multiply here to here, so 2 times 4 is 8, and the x comes with. Then I'm going to multiply this second row times this first column, which is 3 times 1, which is 3, and the x comes with. And then the last one will be 3 times 4, which is 12. Now, what you should notice, or hopefully now you're noticing it, is I would say the majority of the time, especially because we're not together and we're going kind of basics here, most of the time what will happen is this diagonal will be like, and that's even when I make much bigger problems, unless I get sassy. A lot of times what will happen is, I would say like 95% of the time, those diagonals will combine. This 2x squared is the biggest in terms of power, so we're going to write it first. Then notice I have 8 x's and 3 x's. If you've been practicing your adding and subtracting, I just take and combine those. If I have 8 x's in one basket and 3 x's in the other, 8 plus 3, 8, 9, 10, 11. That'll give me 11 x's. And then I have plus 2. And there's my answer. Now, what if I had flipped it? Watch what happens. I get 2x squared. Same. All right, now I'm going to get 3x. And then I'm going to get 8x. Not the same, but because they combine to like, 3x plus 8x is the same as 8x plus 3x. So even though my problem looked a little different to start with, what's going to happen is my answer is going to be the same because all that happened is my diagonals flipped their location. Right? And then 4 times 3 is 12 again. So I get 2x squared plus 11x plus 12. Okay. Now I'm going to do another one. I'm going to do one that's got maybe some negatives and that sort of thing. All right, but I'm still going to follow the same pattern. Okay. And then I'll do one that's a little bit bigger so that you can see what that looks like, so you can see why box is a nice method for that. All right, so say I've got 3x minus 5 times x plus 2. I didn't change the powers because that will change my diagonals and make it so I don't have like unless I make them both squareds. And I just want to keep it sort of simple for now. All right. If you need your little invisible ones, go ahead and put them on. All right. 1 times 3 is 3. X to the first times x to the first. X to the second, right? 1 and 1 make 2. Negative 5 times 1, and this is where I lose students all the time. I get students that multiply here. I get some students that tell me it's 6 because in their brain they start thinking about adding and they think, oh, 1 plus 5 is 6. I also get students that forget the sign all the time. Be careful. You multiply into the box. You add, subtract out of the box. Okay, so just be really careful. Students that are very fast at math have a tendency to go too fast and make silly mistakes. So just watch yourself with these. And I still keep an x here. All right, now I have 2 times 3, which is 6, and I keep the x. And then 2 times negative 5 is negative 10. Now, when I go to collect my like terms, I notice that these are like, but they're opposite sign. So I'm going to take 6 minus 5, which is 1x, and then minus 10. All right, it takes practice. All right, so there's going to be practice hanging around in Google Classroom, I really recommend that if this is something you haven't done in a while, that you do some of the practice problems before you jump into the actual assignment. All right, if the actual assignment doesn't go well for you, what we'll do is we'll get together during office hours and I'll help you through some problems and you'll have to show me your work. All right, but you need to show me that you can do this. Okay. All right. The next one I'm going to do is just one slightly bigger one. Maybe I'll do a 2x3, just so you can see that this is why I like box method. All right. X plus 6 times 3x squared minus 2x plus 4. Okay, so now this is a 2x3, and what's going to happen is I'm going to do 3 across the top and 2 down the side, and I'll get a 6 box. All right, but this is why I like box method, because you can't do this with FOIL. If you were to try this with FOIL, you would do first, outer, inner, last, and you would miss that middle term altogether. You can do distribution, and I have students that do distribution all the time and love it. So if you like distribution, go ahead and do it. I like box method better for a problem like this because I lose stuff. I have a tendency to lose pieces, and this helps me not lose pieces. All right, so there's my x plus 6. I have 3x squared minus 2x plus 4. All right, here's where you really need to watch for powers. 1 times 3 is 3. X to the first times x to the second gives me x to the third. And you generally will be right, if these are in a nice numeric order, like if I've got a first power and no power, second power, first power, no power. What should generally happen, and it won't happen all the time, but most of the time what will happen is you'll end up with like terms on these diagonals. Okay, 1 times -2. -2, x to the first times x to the first is x to the second. 1 times 4 is 4, and it's positive, and then the x comes along. All right, 3 times 6 is 18, and the x squared comes along. 6 times -2 is -12, and the x comes along. And notice, x squared, x to the first, x to the first. All right, and then the last one, 6 plus 4 is 24. Now, when I pull my pieces out, I'm going to combine my like terms. All right, so I have 3x to the third. 18 minus 2 is 16. The power doesn't change, okay? Be careful. Into the box, you get more power because you're multiplying. Out of the box, you just pull out your like. -12 plus 4 is -8x. And if you have trouble with the signs, go ahead and just use a calculator. You're completely allowed to do that. All right, and then I have plus 24. Notice my answer's a lot bigger, but that's because I started with a bigger initial problem and I didn't really get much canceling. There are times when you multiply where you will get things that cancel, things that go to 0. I'll probably do a couple of those in my FOIL video, but hopefully this gives you an idea for box. Now, if you find that you are still struggling with box, or you want like the actual one-on-one interaction because it wasn't enough to watch me do this on video, that's totally fine. That's what my office hours are for. So come to office hours. If you're like, Miss, I can't make your office hours, message me and we'll set up a time that we can do a meet. All right? Math online is hard to do, all right? Most people are not successful when they can't interact with the person teaching them math. So this can be hard for people. If you have questions, make sure you ask them and make sure you get the help because you need to get through the assignments to get through the class, all right? So you can send me a remind. You can message me on Google Classroom. If you are not my student and I don't know why you're watching this, but you have questions, you can always leave me a message in the comments below. I like below. My brain hurts. All right, so I hope this helped, and I will talk to you later.